So in this problem, the coordinates of the vertex and the coordinates of the focus of a parabola are given to us. We need to determine the equation of this parabola. Let us begin. So let's try to understand the problem graphically here. So let us consider a straight line. On it, we're going to consider 2 points. One of the point is going to represent the vertex of the parabola with coordinates 5, 2, and the other point is going to represent the focus of the parabola with coordinates 3, 2. Now, according to definition, any straight line on which the vertex and the focus of the parabola lie, that line is going to be referred to as the axis of the parabola. So what we'll do, we're going to choose another point on the same line. Let's say it's denoted by A with coordinates A, B. Now, point A is chosen in such a way such that its distance from the vertex is the same as the distance of the focus from that same vertex. So this length D is exactly the same. Now the reason why we're choosing the third point A on this axis of symmetry line, we're going to pass a line through it, and it's going to be perpendicular to the axis of symmetry line. And this line is referred to as the directrix of the parabola. So that means in order to find out the equation of the parabola, we need to obtain the equation of the directrix and we need the focus. The focus is already available to us. So our first goal will be to find out the directrix. Now to find out the equation of the directrix, we can use the point slope form of a line, which states that if we have a straight line passing through a point with coordinates x1, y1 and the slope of that line is known, then the equation of the line will be given by y minus y1 equals to the slope multiplied to x minus x1. So that means we need the coordinates of point A and we'll need to find out the slope of the directrix line. So what we'll do, we'll start with the slope of the axis line. So the slope of the axis line let it be m1. So that will be equals to, we'll have to take the ratio. In the numerator, we need the difference of the y coordinate, and in the denominator, we need the difference of the x coordinate. So we'll do vertex minus focus. So that means we'll take the difference of the y coordinate of the vertex and the focus. So that's 2 minus 2 divided by difference of the x coordinate. That's 5 minus 3. This will be equals to 0. So that means the slope of the axis is 0, which means that it is parallel to the x-axis. Now, if the slope of the line is parallel to the x-axis and it is 0, it means that the directrix line is going to have an undefined slope. And if it is undefined, then it's going to be parallel to the y-axis. And we know that any line which is parallel to the y-axis, its equation will be given by x equals to A. Now here A is going to be the x coordinate of point A or the x coordinate of the point through which the directrix line passes. Now we need to find out the value of A here. So let's label this as number 1. Now to find out the value of A, we're going to use the fact that the vertex V is the midpoint of the line segment joining point A and point F. So we can use the midpoint formula. What we'll do, we'll take the sum of the x coordinates of point A and point F. So we have A plus 3 divided by 2. That's going to be the x coordinate, and the y coordinate will be sum of the y coordinates of point A and point F divided by 2. And this coordinate value is exactly equals to the coordinates of the vertex. So that's 5, 2. So when we solve for the value of A and B, so A will be equals to 7, and then we have B that will be equals to 2, which means the coordinates of point A, that's going to be 7, 2. Now that we have the coordinates of point A, we can easily find out the equation of the directrix. So the equation of the directrix will be equals to, we already have defined that's x equals to A, so x will be equals to 7. Now we have the equation of the directrix. So using the equation of the directrix and the coordinates of the focus, we can easily find out the equation of the parabola. So let us begin. So here we have the coordinates of the focus on the axis line, and then we have the equation of the directrix. We're going to consider a point P on the plane. P is going to be the locus of the parabola, such that if we join P and F, and if we drop a perpendicular from P on the directrix line, then this length PF will be exactly equals to PM. That's the definition of a parabola. So by definition, we have PF equals to PM. So here PF can be easily obtained by using the distance formula. So we'll take the square root. Underneath the square root, we need the difference of the x coordinate. So we have x minus 3 whole square added to the difference of the y coordinate. So we have y minus 2 whole square. And this will be equals to PM is the perpendicular distance of the point P from the straight line. So here we'll have to use a formula. So let's say we have a point with coordinates x1 comma y1, and we have a straight line with the equation ax plus by plus c equals to 0. So this is the standard form, general form of a straight line. Now if we are going to draw a perpendicular from the point P, so this is the point P on the straight line, then the perpendicular distance is going to be given by the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared, which means in our case we have to rewrite the equation of the directrix line in the general form. So we can rewrite it as 1 times x, there is no terms containing y, so we can rewrite it as 0 times y minus 7 equals to 0. So that means we have 1 times x plus 0 times y minus 7 divided by the square root of 1 squared plus 0 squared. Now what we'll do, we will further simplify. We have square root of x minus 3 whole squared plus y minus 2 whole squared. So this will be equals to the absolute value of x minus 7. We're going to square both sides. Squaring both sides gives x minus 3 whole squared plus y minus 2 whole squared equals to x minus 7 whole squared. So let's expand it. We are going to get x squared minus 6x plus 9 added to y squared minus 4y plus 4. That will be equals to x squared minus 14x plus 49. So here we can cancel out x squared and x squared. We're left with y squared. Then we have negative 6x, and then we add positive 14x to it to get plus 8x. Then we have negative 4y. Then we have 9 plus 4, so that's 13. 13 minus 49 is going to be negative 36 equals to 0, and this is going to be the required equation of the parabola.